Hello, friends. Welcome to the ATC Double Cut. Today, I have a special guest joining from the central part of the United States. It is Dr. Bill Kreuser. Welcome, Bill.
Hey, Micah, how you doing?
I am doing well. It has been a while since we talked, and I thought it. I've been thinking that I should have you on to the ATC Double Cut sometime, and then I recently was thinking about plant growth regulators and growing degree days and reapplication intervals. And I had some questions. I wanted to ask you about it. I did. I sent an email asking about it. And at the same time, I said, hey, can you join me on the ATC Double Cut to talk about this also? So thank you for fitting this into your schedule.
Yeah, no problem. Excited to be here. It's great to listen. So it's cool to be a guest.
All right. Well, you are currently the golf course superintendent at the Agar Junior Golf Club. Is that how it's pronounced?
Yep, Jim Egger, Memorial Junior Golf Course. It's a little 9-hole facility here in Lincoln, Nebraska. It's part of the city parks golf courses. There's 5 courses, and I get to take care of the par 3 course. 9 holes of bent grass, tee screens, and fairways. It's kind of my little playground where we get to really push turfgrass performance and test some of our theories about how to manage golf for the game we all love.
Awesome. And you're formerly a assistant professor or
Yep, for
at
7.5 years at the University
mhm.
of Nebraska, doing research in precision turf management, studying things like different crop sensors, thermal imaging, but really focused also on managing growth rate, fertilizer additions, and specifically how we're to use our plant growth regulators most effectively. It's a line of research that we started back in 2007 to solve a question of how do we manage primo when you're managing grass, bent grass growing in shade at my parents' house on their backyard putting green. And that line of questions has led me all the way to here and talking to you.
And you also I saw in your Twitter profile, and I'll show your Twitter handle in a bit, but your Twitter profile says you're the inventor of GreenKeeperApp.com, and I suppose you're a director or something also. It's not that you just invented it and let it go, but you also run that Greenkeeper app business, don't you?
Yeah, so Greenkeeper, when I applied for my position in Nebraska, I said, I'm going to, if you hire me, I'm going to build this application. So got the job and started to build it and continued to grow it from the little small app that it started off. And now it's been continuing to grow. We have a team of 6 full-time professionals working. And so I'm the president of that company, constantly keeping a team of computer scientists busy and we're reviewing what they're working on. So it's been really great as we've grown. Now I left the university, mainly to run this application. The university said, we need to keep growing this. So we actually were awarded Startup of the Year in 2020, I think, from the university. And so that's a big part of what I do is just continue to bring a lot of the science that we all work on together and simplify it into a tool that any turf manager can easily use some of the concepts that we talk about collectively as turf researchers.
Cool. Wow, that's busy. Did you say it's you plus 5 other people full time
Yeah,
on Greenkeeper
yeah,
app?
yeah. And then we have some part-time researchers in the summer, help with plot research. We have some interns in the computer science world. I do all the design, testing, even all the mock-ups. So how does it look? I draw all that out for the coders because they do a good job of taking those designs in and figuring out how to actually make it work in a web browser. So it's busy, and I'm also doing sales too. So I'm around the country talking about research and talking about Greenkeeper and helping people get their courses set up. So it keeps me on my toes.
Yeah, I can imagine. I saw you guys you started a Greenkeeper app YouTube channel. And I'm waiting for you to start a podcast because it seems like everybody's doing a podcast too.
I
So
know. I've wanted to do a podcast like years ago honestly when Joe Galati started doing his podcast, like I was like, oh, this is a great idea. but then it just, people were doing it, and I just felt like there's too many of them now. So I feel like I've kind of missed the boat on the podcasting. So I haven't even really tried.
Yeah,
We do
yeah. I thought I kind of missed the boat on it too, but enough people suggested to me that maybe people would rather listen or watch rather than read. And so I was encouraged to do it, so I gave it a try. But then I felt like, yeah, it's just like adding one more podcast to an already crowded field. But then even now, there's still people still continue to do it. So I guess it's just survival of the fittest.
Well, I
People
got to
because
think, I'm
people have
mowing
a limited
greens,
amount of time.
but I'm mowing greens in the morning to take me an hour and a half. So I can do a lot of podcasts just doing one morning task. So, you can quickly fly through a whole library of episodes within one podcast. So maybe there is still some space there.
Yeah, maybe there is. Do you when you listen to the ATC double cut, do you speed it up? Do you listen to it at increased speed?
I'm usually I usually just push play. I've done it before. I'll listen to like 1.1, 1.2, but it's not crazy. I
Oh,
remember at the
cool.
university, our students would say, especially during the COVID closures, they would listen to all our lectures at like 1.5 times
Uh-huh.
so they could fly through the lectures. So
Yeah.
I'm not to that level.
Yeah, I guess with sometimes I listen to my episodes just to check the audio quality or to check if I've forgotten what we've discussed or something, I'll listen to it again. But I can't listen to myself at regular speed. I always speed it up. So I'm I'm glad that you can listen to it at regular speed. All right. Well, with this being a double cut, and I put up on the screen your Twitter handle. It's at PGR Bill, PGR for Plant Growth Regulator. So you can follow Bill on Twitter there if you like. This being the ATC double cut, I think you kind of know the conceit of the show, which is we use some post from the ATC blog as a starting point for the discussion. And I am bringing up on the screen now, and I'm going to show this post with the title "Using Plant Growth Regulators on Golf Course Putting Greens." I will put a direct link to this post and to the article that it's referring to. I will put a direct link to that in the show notes so you can check it out. I didn't realize, but well, I mean, I knew it was a long time ago, and I, I, I didn't quite realize it was 2015 though, but time goes by fast. So this is an article from 2015 from the USGA Green Section Record that you wrote, and I thought it was superb. And because I thought it was superb, I as soon as that was published in the Green Section Record, I did a blog post about it, and I said Bill Kreuser's. It's a one sentence blog post. it's one. Those are the easy blog posts to write. I said Bill Kreuser's article in the USGA Green Section Record, "Effective Use of Plant Growth Regulators on Golf Putting Greens," is one you'll want to read now and keep a copy handy for future reference. And that was an article that was very impressive for me back in 2015. And I read it again today. I hadn't read it recently, but I read it again today, and I was impressed with the content. And I wonder if you've read that one recently, and if you think it's still useful today, or if you would say throw it away. There's better articles to read right now.
No, I did write it years ago, but a lot of the concepts and science there are still, I think, top of mind for a lot of golf course superintendents. So I think it's still very pertinent. There's some just general descriptions of how these products work and how they manipulate growth rate. And then we go a little bit into some of the scheduling and then move into some of the plant health aspects. So it's fairly comprehensive, but there's definitely been some new work that's came out of this, particularly on maybe some of the work with collars and mixtures of PGRs with DMI fungicides. That's all of our more latest research. So this was kind of our first foray into it, but we didn't even have the warm season models done at the time of writing this. So it was really focused on what we've done from on the bent POA side at the first, and now that whole suite of information is expanding.
Yes. I read it and I was like, okay, like back then when it came out in 2015, it was like so cutting edge, and it's like, wow, this is explaining the different types of growth regulators. It's explaining the principles of growing degree day models, and it's explaining the one growing degree day model that existed at that time, as far if I remember correctly, which is just the one for creeping bentgrass, and basically a 200-day, is it a 200-day reapplication interval with the
Yep,
base
200 growing
zero?
degree day. Yeah, base 0 Celsius. So it's Celsius
Hmm.
scale. That still gets messed up with superintendents. Um, I'll hear people say, "Well, I use a base 32 Fahrenheit." So, okay, well then you're applying 1.8 times too frequently. So we want to make sure we're in the right unit, the right
Hmm.
base temperature. The warmest using grasses are still in Celsius, but they need a base temperature of 10 because that's when those grasses start to slow down their growth rate. You can see that in your growth potential equations.
Hmm.
And so we have to account for that if we're doing any of this type of modeling.
Well, good. So because that's such a short blog post, and we're not going to go through that article because we're going to talk about what's happened since 2015. But I think I will still recommend this article, and you would still recommend this article and say it's a good foundational reference for growth regulators, and it describes what the plant health benefits are and why you might use what you could achieve by using plant growth regulators compared with not using plant growth regulators, why you might want to use them. And I don't think there's been too much new in the plant health arena with.
Yeah, that's not too much. I think the thing that we've gotten in trouble with is we've struggled or we've emphasized that plant health or the density or the color side so much that we've forgotten the main reason we're using these materials, and that's to manage our growth rate and the benefits that they provide by managing growth rate. And so all of those other things are secondary to having the right amount of consistent growth suppression. So a lot of our research since then is what is the right amount of growth rate and how do I use these materials to help us hit that goal? So let's refocus on and not worry as much about plant health. If we're doing the growth rate management part correctly, all those other secondary things will start to come up. But if we're thinking, I'm just going to use this product willy nilly at high rates or tight intervals to maximize density, you actually might be having a detrimental effect on the plant that could be causing other types of problems.
Yeah, like so I'm not a specialist about plant growth regulators, and that's why I wanted to talk with you. But sometimes people will ask me the question, like, I'm doing a grow in, so should I use Primo to speed up the grow in because it's gonna make more roots and it's gonna make more rapid lateral growth? And I'm just sort of like, I'm I I think that those things might happen in a certain case, but it's not necessarily going to make your growing happen faster.
Well, and gibberellin is so important for a seedling to develop into a mature plant. And so I'm not a big fan of using even the class A PGRs, Primo and Anu, to try to change those GA levels when that plant is naturally going through a progression of physiological changes to become an adult plant. So I personally don't like using a PGR until you've had half dozen mowings onto that stand and it's starting to naturally develop its own tillers and you have a stand there that looks like a green or a fairway. Well, then you could start adding those materials because you are likely putting a lot of end down, so we can actually help to promote some lateral growth. But I don't want to do it until that stand is at a level where it's looking like a stand of turf and not just a bunch of little seedlings all around.
Very good. I agree with you about that, and that's the type of advice that I try to offer also. Now, let's talk about warm season grass, and let's talk
Sure.
about growing degree day models for a while. I guess let's start with bent grass. So you did the research at Wisconsin for your master's degree with growing degree days, right? Is that where that
Yeah.
kind of started with Doug
Yeah,
Solbach?
that originally started. I was actually an undergrad. I was embarrassed about the study, so I hid it on one of the research greens until it started working, and then I showed our friend Doug Soldat. I said, "Hey, look at this! I think this is working." So that was back in 2008, and then worked on that for my master's. Then went to Cornell and primarily focused on Civitas, but I also still had some PGR work happening in Ithaca, and so our models were working there. And then when I got to Nebraska, we decided we need to start expanding this to model the performance of all of our different PGRs, so Primo, Trimit, Cutlass, and Anu, and we need to start modeling it on different grass species, but also on different mowing heights because we were seeing different mowing heights effects. And then finally, back in 2017, some of our research friends at NC State, Auburn, uh, Tennessee, and Mississippi State all said we want to work together to do a collaborative study on Bermuda grasses and see if we can build similar growing degree day models for our Bermuda grasses. So continue to really expand that research set. Now we're even doing it on DMI fungicides. And most importantly, we also developed a model or a way to understand how mixtures of all of those things are influencing growth rate. So we've came a long way, and a lot's happened in the last 7 years.
You know, the how much of this is proprietary and within GreenKeeper app, and how much of it is public information? Because like I know, okay, for putting green, height, creeping bent grass, and the use of Primo, I know you've published an article or articles that
Yep. So
are
we've
public
published
that says it's 200, but
we've
how much of
published for bentgrass with Primo. I think we've also published for bentgrass with Trimit and Primo Trimit combinations. We've also published for the ultra dwarf Bermuda grasses with Primo and the new. That was in Crop Science. So
that's the
a
one
lot
that
of those
that's the
core
article
ones.
that Eric Razor was the lead author
Yep.
on, and you were
Yep, Eric was the
the
lead.
senior
I'm
author?
on the corresponding on it, but Eric was the lead in writing it. So it was great for me. I could just design the experiment and did the statistical analysis for them. They did all the hard work of writing it and collecting all those clippings.
Hmm.
But then, yeah, we really learned a lot. So a lot of that is in here. And then sometimes the greenkeeper models, we use meta-analysis. There's a lot of growth studies from the 90s, especially in Bermuda grasses, that we can look at what the suppression was, say, in Clemson in the mid 90s, pull the weather records from that time period and try to get an idea of are the models holding up. And so as we've moved into some of the warm season spaces, we've been able to validate our models based on meta-analysis of past research papers.
Wonderful. That so can you share with me, let's go let's consider putting green turf for
Mm-hmm.
warm season species, and let's talk about Bermuda grass first.
Sure.
So you I just had a look. I read the abstract just before our call, and I read the abstract of that Razor paper, which was growing degree days for ultra dwarf. If anybody, I'll put a link to all these articles that we're talking about. This is why I'm going to listen to this at 2x speed when we're done, and eventually I'll put links up to all these articles. That one said 216 to 230 growing degrees, base 10 Celsius was the predicted reapplication, the predicted optimum reapplication interval. Is that correct?
Yeah, so we'll say it's around 210 to 220 for Primo on an ultra dwarf green. That same research found that a new lasts significantly shorter on ultra dwarf greens, which is interesting because on bentgrass, a new lasts slightly longer by 20% maybe. Um, but it's about half as long in a Bermuda grass setting. The thing I wouldn't emphasize too much is the exact interval. That is a little bit of a um, sometimes undue precedence or weight can be put on that hard number. What we're trying to do is when you have peak suppression, that's when the levels of the PGR in the plant are starting to get so low that the suppression is no longer being held in check by the growth regulator. And so your next application generally needs to be slightly after peak suppression. And so we just normalize it and say, we're going to do a value of like 30% later. So if peak suppression is at 150 at about 200 to 220, that's when the next application is due, because at that level, there's essentially no PGR in that plant, and we need to reestablish it with a follow-up application.
Right.
So as
this
the
is to
one is
try
starting
to
to, yep,
this is to try to achieve that consistent growth suppression. So
yep,
when we're talking about the reapplication intervals and growing degree days for this one with ultra dwarf Bermuda grass, right now we're talking about a base 10, which means if your average temperature is 30 degrees Celsius, which would be a very hot day in Bangkok, which is about what we'd be experiencing in Bangkok right now, then you'd have 20 growing degree days because you're base 10. So you have to subtract 10 degrees from your average temperature, right?
exactly. So if we're at a 220 interval, that's when we're saying you should likely have to reapply. That would mean that you need to be reapplying every 11 days.
That's correct. So I've calculated that. And actually, so in Bangkok, it's usually going to be 26, 27, 28 degrees. So it's an 11 to 14 day reapplication interval, according to what that article predicted. However, and now I want to bring up research that some other people published, which is Brown et al., which is some research by Scott McElroy's group, I think, and some Italian researchers were also co-authors on some of these,
Yep.
and that's from Auburn. So they used base 0, and they also were looking at ultra dwarf. I think they were looking at mini verde, and I just read those abstracts again from those two papers, and they're coming up with a different reapplication interval. So they're recommending 100 to 200 growing degree days base 0, which in Bangkok is every 7 days. And so that's like, and you're recommending 11 to 14. So I'm a little bit, I see this research, and I know you're doing additional research about this. I
Hmm.
would like you to give some advice, because I know some of the people listening here might be in Hawaii or in Florida or in Dubai or in
Yep.
Brisbane or places around the world that have warm season putting green turf. And it seems so cut and dried what we should do with bent grass. And the growing degree day models seem really clear. It's not so clear to me what the best practice is for ultra dwarf.
Yeah. So talking to Dr. McElroy and Jesse Brown, when they did their analysis to fit their model, they looked at different base temperatures. And so we did the same thing on the cool season grasses. And when you had a base temperature of 0, we had the least variability in our model. So they did the same thing, and they found that 0 was slightly better than 10. But then I said, well, how do you account for the spring and the fall? And then they say, well, people just don't put down PGRs during those times. This is only for the summer. So the domain is at a different area. It's subject to what they claim is when you should be regulating the growth rate of Bermuda grass. Whereas a base 10, we still had a lot of good, our data came from 3 different sites. And Dr.
So that
McElroy's
was
data too.
Mississippi,
Yeah,
Tennessee. It was
Mississippi.
Knoxville, Mrs. Starkville, and Raleigh. Is that right?
Yes. Yep. And then again, it was evaluated again based on data that came from past papers. And so without having that other paper in front of me to see why theirs was so short, I'm pretty familiar with that work because they were asking a lot of questions on how to do this research. And so I don't see how recommending 100 growing degree days base zero for applications in the South makes much sense. It seems like a lot of PGR going down. And actually, from that study, they were applying Primo and a new, I think, definitely Primo at 100 and 200 growing degree day base zero intervals, the way that I did when I first started this research. And they were getting over 95% suppression within a matter of 6 weeks after they did those intervals. So yes, they were maintaining suppression, but the amount of suppression that they were maintaining was incredibly high because they were accumulating, or like Frank Rossi calls it, stacking all these applications on top from each other. So they were able to maintain consistent suppression, but it was also consistent suppression at 85 to 95% suppression, which just is an incredible amount of growth suppression and can be really detrimental to the health of the turf.
And what
Whereas our
happens to
model,
your
we're trying.
collars?
What's
What
that?
happens to Bermuda grass collars if you suppress the putting green height turf at 80% for 2 or 3 months? What happens to the collars when they get that same rate?
That's a good question. This last year, we started a modeling study with our friends down at PGA Frisco in Frisco, Texas, on their Bermuda grass driving range tee. And we applied the low to high rates of Primo and Anu. We also included Cutlass for Primidol at different rates. And then we did combinations. So we had 14 different treatments. And so it did seem like that the PGRs lasted a little bit longer at collar height than they did at greens height, even in Bermuda grass. We know that happens in the cool season world where the PGRs last nearly double as long on a collar than on a green. It's not as substantial on Bermuda grass, but what that does mean is that even if it lasts slightly longer, if we're making applications on the greens height and that same application is more efficacious on a collar, you can more quickly develop really rapid levels of growth suppression that can really suppress growth rate. And one of the interesting things with collar decline and cool season turf is, in addition to the collars being more sensitive, so the PGRs last longer, we get more suppression out of them, they're also growing slower because they're at a higher height. So now we're putting a really aggressive PGR program onto a collar that's growing at a slower rate than the green next to it. And so the absolute growth rate, the amount you'd measure with clipping volume, is minuscule. You put any kind of wear, tear, traffic, any other type of stress on that collar, you have collar decline symptoms showing up. So not exactly sure on the Bermuda grass how much the growth rate varies on, say, the collar height versus the greens height. Are they similar? I tend to think they might be growing at a fairly similar speed. Haven't really evaluated that. I do know that collar height on bank grass and POA grows at a much slower rate than greens height. Even going greens height from 120 in a study we did, a 2-year study, to 80,000s, we grew about 50% more grass at 80,000.
Yeah, that was crazy. I remember that one. I think that I never would have expected that. So I'm glad you did that experiment. It helped me to understand a lot more why the plant growth regulators would last longer in collar height turf, because it's not intuitive at first, because you think like the grass at the higher mowing height it's going to have a deeper root system, it's going to have more carbohydrates, it's going to be a healthier plant, a bigger plant, all of these things. And like, so I was thinking that the plant growth regulator would have more of an effect on the lower height turf, but if I understand right, it was growing 55% faster, and so you're
Yeah.
actually just mowing. It's growing faster, and then you're mowing off more of the
Yep.
PGR.
And for it to be growing faster needs to make more of that hormone gibberellin. So it's going to take a higher effective dose to suppress all of that production. Where
Hmm.
grass that's growing at a slower, it's at a more ideal leaf area index, a more happy mowing height, we could say. It's not making as much of that gibberellin. So it's easier for the PGRs to suppress that growth rate. So all those factors together. Another factor too is the grass at greens height is hotter in a thermal image than the higher height grass. So the metabolism inside that grass is going at a greater rate. So there's all these factors that are leading to these differences in PGR performance that can be related to so many different aspects of management and culture.
Okay. Let's I've got a lot of things that I want to talk about, um, and you provide so much insight about. Let's wind up with Bermuda grass for now
Sure.
by saying if we just want to have consistent suppression, and let's assume that our growth rate is the way we want it, so our clipping volume is the way we want it, and the grass is healthy. What type of growing degree interval would you recommend for an ultra dwarf Bermuda grass putting green for reapplication of Primo?
For Primo, I would firmly be on an interval around 200 to 225 growing degree days. That does give you a little flexibility, even in Bangkok weather, where you might be plus or minus a calendar day. And so
Mm-hmm.
I think that's one thing I want superintendents to know is just because the model goes off and says you have to apply on Sunday, you can probably stretch it out to Monday. You might lose a little bit of suppression for a day, but it's going to go back.
Yeah.
It's only if you're off by 3, 4, 5 days that you can, in either direction, either have an increase in suppression or a substantial reduction. So target that 200, 220 growing degree days for Primo. If you're doing a new, it's around 120, 130 growing degree days, somewhere in that interval. But again, there is a little flexibility in there to be, plus or minus a day.
And if you want to start mixing PGRs and accounting for your fungicides that would have suppressive effects and so on, it gets complicated enough that you really just want to use the GreenKeeper app, right?
Yeah, it does, because when you start when you start mixing PGRs, it's an additive effect. So if you're getting 20% suppression today from Primo and 30% from a new, you're going to get 50% combined. If you're getting 10% suppression from Densicore, then you're going to be 60%. And obviously, you could get to a number that's greater than 100%, which is impossible. You can only PGRs and gibberellic acid induced growth elongation represents about 95% of all of the growth rate of our grass. So that's kind of our theoretical maximum, and that's actually been measured with really high levels of PGRs, and say the most suppression you're going to get is an average of 95% maximum. So
So
what
if
we're
you
able to do in Greenkeeper is do a linear plateau model. It just accounts so that as the suppression values start exceeding 100%, well, then that means that you have 75% total suppression. If you have 150% combined suppression from all those stacked up applications and DMIs and everything, well, that equates to 85% suppression. And finally, when that totals around 200, then you've really shut down all elongation growth, and you're at that 95% suppression. So Greenkeeper does take all those different things and show how they're all working together.
tell me that again, the maximum suppression you can get is 95% in reality. So
Yeah.
we're talking about like your dry matter yield would be 5% of the control if you completely shut down gibberellic acid
Yeah, you're still
production.
getting cell division happening and some level of elongation, right at the base or the crown. But then most of our growth rate is a result of production of this hormone gibberellin.
Hmm.
And so if you eliminate gibberellin production, the leaves are still growing, but it's just through basal cell division and pushing up of new leaves as they're dividing out of the crown. It's that elongation growth that lets those small cells balloon up to be their full size. And so that's the theoretical maximum. And it's not us theoretical, it's something we've measured in greenhouse and in the field. And you always come to about 93, 95% is your average. And you get to the era of collecting clippings at that point too. So, getting it exactly there, hard to say,
Do you
but
have
that's your
phytotoxicity
theoretical
when
max.
you do that and you basically stop the grass from growing? Is it yellow at that point, or does it still look
No,
good?
not necessarily. But if you put any type of environmental or other type of traffic stress on it, then we can start to see um, really bad problems. I think on the warm season side, it goes yellow. On the cool season side, it gets this dark bluish brown hue to it when you have that level of suppression. And even at that level, you start wondering, are we affecting other things in the plant? But you'll definitely see that it looks kind of bad. We did one of the first studies we did on cool season athletic fields in 2009. We suppressed pretty much all vertical growth. Those plots looked brown, but if you got on your knees and looked at them, it was brown because the leaf tips were so sheared by the mower constantly hitting them and damaging them, but it wasn't able to grow up enough between mowings. So the mower just kept hitting the same spot. It's kind of like having too high of a reel speed on your greens mower and you're beating up the tissue.
Mm-hmm.
But then down lower, the grass was real dark and green. But it just, you putting traffic on that plot, it's not going to recover fast enough. It's going to go away.
Wow, I'm learning a lot. I hope the people watching and listening are also able to follow along and can learn. I suppose that anybody who's listening to this conversation is a turfgrass professional and somebody who's quite interested in this topic. So I suppose you're learning just as much as I am. Now, Bill, let's move away from talking about Bermuda grass, and I'm going to start talking about paspalum and zoysia putting greens very soon. But let's talk about growth rate in general, and about how, as I wrote in the introduction to my short grammar of greenkeeping, and I think the first chapter was also about growth rate. It occurred to me at some time in my career. In fact, I think I remember when it was. It was in 2010. I realized that getting the growth rate right was really important, because if the grass grows too slow, we have all kinds of problems. If the grass grows too fast, we have all kinds of problems. And things like adding irrigation, adding fertilizer, and and adding plant growth regulator, they're all done to adjust the growth rate of the grass. But really, the overall goal is to get the right growth rate. And so I think we've been talking a lot about PGRs. They could be used like this. They should be used like this. If you're using it trying to get consistent suppression, we should like do exactly this many growing degree days and plus or minus, some leeway. And we talk like this, but actually I think that you would also say that the primary thing is to get the right growth rate. And if you've got the right growth rate, you may not even need to use PGRs.
Yeah.
So can I hear your perspective on that? Because I've actually been more and more seeing that around the world of people just applying plant growth regulators on a calendar schedule. People still apply on a calendar schedule sometimes, or they apply on a growing degree day schedule, and they're so concerned about applying according to a model or applying according to the way they think they should do it, that I think maybe they're missing something when they could just be using it as a tool. So I would like you to tell me your thoughts on the best way to use it and how it's linked with growth rate.
Sure. So I obviously, at our par three course, we manage our turf with different PGRs, even across different greens. We have 10 greens on 3 different PGR programs. The collars are on different programs. The roughs and surrounds are on different programs. I think the PGRs definitely have a good benefit to elicit a lot of these secondary benefits: increased color, density, plant health, annual bluegrass control for my neck of the woods with something like a trimmet. But we want to make sure that we're doing it. We're trying to figure out how much suppression we need at any given time. And if I don't have clipping volume, I don't really know how I schedule any of my PGR applications, because we need to think about, primarily, we're using these materials to help us hit a growth rate target. At my course, it's between 1 and 1.25 liters per 100 square meters, or quarts per 1,000 square feet, whatever unit you're comfortable in. in that if I'm there, I know that my greens are performing well. I'm still getting my green speeds plus 10 feet, but I'm recovering from ball marks. We had 26,000 rounds, mainly in the summer, on 1 acre of greens. It's a lot of ball marks. It's a lot of wear. If I go lower than that, the greens are going to run 12 feet. And they can do that for a few days. I do that for a couple of weeks. And then all of a sudden, you're going to see the wear and tear on that turf. So there is this optimum. So 2 years ago, 2021, I went in and said, let's just regulate these greens really aggressively, 80% suppression or more all season long. What I noticed is I needed a lot of fertilizer to keep my growth rate high enough with that much suppression to manage that value of 1 to 1.25. And it was really not a really efficient way of managing, because I was putting a lot of product down to suppress growth, removed a little bit of clippings over the course of the year without suppression, but I needed 3.5 pounds of N to support that growth. And when I did the end of the year calculations, I removed about 200 quarts of clippings, which is around 3/4 of a pound of nitrogen. So I put down 4 times more fertilizer that year than I took off. That's just, where is that fertilizer going? It's sitting in the soil. I saw an increase in thatch accumulations. I have to cultivate more now. I need to top dress more. So last year, we just said, let's simplify this system. We're going to fertilize whenever the grass is giving us indication that it needs more fertilizer. Is it thin? Are we seeing moss and algae? Is it slow to recover? Is the color not right? Then I'll change my spoon feeding rates. But then I'm going to use my PGR program kind of as almost a separate thought. Like, I'm going to fertilize first, and then looking at my 7-day average growth rate, if I'm seeing values closer to 2, well, then I want 50% suppression. If I'm seeing values closer to 3, I'd want 65% suppression. So I'm trying to look at what's my growth rate right now, and then figure out how much suppression I need. And I do that by either using different rates of a PGR, mixing PGRs together, or mixing PGRs with DMIs. And so I'm really flexible. I'm scheduling my applications based on growing degree days, because I know that the duration of the material, the PGRs, is really correlated to air temperature. So I know when it's going to wear off. The question I have with every application is, how much suppression do I need? How hard do I need to push that brake pedal? So in taking that approach last year, my system became much better, much more balanced. I put down about 1.25 pounds. I removed around 1.25 pounds. All of a sudden, that seemed to be a much more efficient way of managing our turf. And I didn't see the rapid thatch accumulation in that top surface inch either, from putting 4 times more fertilizer down than I was removing in my mower bucket.
Yeah, I think this mass balance approach of trying to figure out what's happening with everything is something that I do a lot of. And I know Doug's been working on that. You're doing that. We're all kind of approaching this from our own way, and we kind of come to the same conclusion that it just sort of makes sense to have the right growth rate and to apply the amount of nitrogen fertilizer that will achieve that, and apply the amount of sand top dressing that's necessary in order to keep your organic material in the top of the root zone relatively constant, assuming that you're in a good place with the organic material. So
it's a good shout out to our late great Dr. Wayne Cousseau, who was talking about this in the 90s: nutrient demand, nitrogen driven demand in turf. And here we are, still trying to figure this out and optimize these applications.
Yeah, that is correct. He would have been great to talk with about this. I know you and Doug got to spend a lot of time talking with him, and there's a lot of wisdom there and a lot of knowledge that we yeah, it's sort of like we're reinventing the wheel or something, because this kind of stuff should be just simple, right? It's like what you just talked about, like that you have better growth rate, and then your nitrogen harvested relatively match the nitrogen applied. It's like, shouldn't that be the goal every year? But we haven't typically thought about that, because I know like what I remember from going to turf school or going to seminars, you typically would learn something like this grass responds well to 3 pounds of nitrogen per 1,000 square feet per year or something. It's never talking about what your grass and it might be in a shaded side or and it might be in a very rich soil or it might be a 40-year-old Kentucky bluegrass lawn that has a high amount of organic material at the surface. That and so all of those situations would mean that you should adjust your nitrogen supply based on how much growth you're getting from that lawn. But instead, we come at it. Eh, I feel like when I was younger in my career, I would have come at it with more of a brute force approach, like I used to do with the organic matter management. As recently as 2014, I was just giving a blanket statement recommending that everywhere should be removing 15 to 20% of their surface area by coring per year, replacing that with clean sand and applying from 12 to 15 millimeters of sand top dressing per year, which is 40 to 50 cubic feet of sand per 1,000 square feet, which is a tremendous amount of sand.
Wow.
As recently as 2014, I was just recommending that everywhere. And the USGA Green section published an article in 2016 that continued to recommend that. And now they published an article in 2019 that cut that back slightly. But now I'm saying let's do it in a site specific way. And I think with fertilizer, I used to be making a brute force approach. Now I don't. With sand, I used to make a brute force approach. Now I don't. And I think with this whole growth rate thing, the clipping volume has just turned out to be so useful. I thought I would get laughed out of the room when I started recommending it. And I know a lot of people did laugh, and some people still do laugh, but it turns out that it's just so useful to know how fast your grass is growing because it leads to improved turf conditions and it leads to better control of a very challenging job, which I know you as a golf course superintendent and as a business owner and boss and scientist and so on, like being a golf course superintendent is not a part-time job, right? I mean, it's
No.
there's a lot of work to do, and then you're doing another job on the side, and in the winter you're going around doing a lot of speaking and conference appearances and so on and trying to do research. So I can't imagine how busy you are with all this stuff. And something like clipping volume, it becomes an essential tool.
I look at it every day. I go into GreenKeeper even on my days off. I wake up in the morning, I pull my phone over, log into GreenKeeper, and I see what my growth rate is from the guys at work collecting clippings that day. And I know you've done a lot of cool things, Micah. MLSN is obviously revolutionizing how people are fertilizing. I think clipping volume might be your greatest research angle or idea that you've brought that's going to have real important impacts on turf, because it's the first time that we made this connection that you can measure something that seems crude, but it's related to so many aspects of agronomy, not just what the soil levels are, but disease and wear and fertility levels and turfgrass performance, and they're all linked back to this idea of how much growth do you need, and then you can apply that to optimize things with MLSN and try to figure out, well, how much of these nutrients do you need at different ratios from a plant need perspective and removal. And it seems to me that it's just a really powerful and really simple tool. Of all the things that we measure, it's really, I use a red body spill pail, a bucket pail that's like 3 gallons, but it has lines on the inside at 1 quart increments. And I just hang it off my triplex and I collect it from 3 greens: my most sunny green, my most average green, and my most shady green, from the center bucket every single day. And
Okay.
it's just amazing what you can learn, even just how the sunny green grows relative to the shady green, and how you can see the shady green is growing 50% faster for the first half of the summer. Middle of the summer, it's the same. And then late summer, it's growing 50% slower. And so there's an example where in the spring, I will sneak extra PGRs on that shady green to help suppress that growth rate compared to the other greens. And then later on, when it's summer and that grass is now struggling because it's burnt all of its sugars up, I'll maybe pull the trim it out and I'll just do a new by itself and get, instead of 60% suppression, 30% suppression. So I'm just taking that little bit of stress off. That one simple 1 minute measurement is allowing me to better manage my turf and keep my grass on the green at the end of the summer under a shady environment. And so that just shows how important and worth that number is.
Yeah, it provides something that turns out to be way more valuable than I ever would have thought. And I was aware of this a long, long time ago. I knew that people were measuring this. We were measuring it when I was a golf course superintendent in Japan in 2000. And I'm not one for busy work, and I'm not one for collecting data that I can't make use of. And back then, all I cared about was dry matter yield, and I knew that I was never going to dry the clippings, and why would you want to anyway? And I thought like the more grass that was growing, the healthier it was, the better, and I would just cut it short or cut it more or roll it more in order to get green speed. I wasn't thinking that if you could really suppress growth back in 2000 and have it growing really slow, it wasn't all connected for me. And I think as I traveled around the world and saw more and more grasses in different growing environments, something clicked where I realized that growth rate is just like critically important. And when you see so many problems, problems are related to the growth rate not being right. And
Yep.
yeah,
And
so
like you said, it doesn't always have to be. Having too much growth rate can be just as problematic. Like that shade green, that just it literally is growing itself to death. That plant only has so much carbohydrate load, and when you get to the heat of Nebraska summer, it can only go so long. We see the same thing in Raleigh. I mean, the bent grass in Raleigh on greens would grow great until end of July, and then all of a sudden, uh, you'd start to see the bent grass greens failing. Well,
mhm.
it grew, it grew, it grew. It loved that warm weather, and then it was out of sugar. It was a dandelion that was sprayed with 2,4-D that just grew itself to death. And
Yeah,
that
that's
same concept is happening on our grasses. And so optimizing growth rate can mean that we can stretch out how long is it going to be able to make a stressful summer period.
right. So that's one of the health benefits, or one of the benefits that you would see from using plant growth regulators is you're able to allow grass to survive heat stress for a longer period of time,
Exactly.
because it's not burning up all of its carbohydrates.
Yep. It's
So,
a mass balance approach. So
all right, now I haven't seen any papers about PGR intervals, growing degree day intervals on paspalum greens.
yes, it's because they don't exist.
Okay. How about
I would
zoysia
love.
greens? So let's talk about paspalum and zoysia greens, which are a thing.
Mhm.
And what does GreenKeeper app tell me if I have those kind of greens?
Yeah, the numbers in there aren't going to be as precise as we would like them to be. Sometimes you just have to look at whatever data source you can get. Sometimes it's proprietary or from talking from people in the manufacturer side to say, this is generally what we recommend, and we can kind of back calculate what that should roughly be. But we need to do the modeling. We finally are completing the modeling for Bermuda grass greens and fairways. Still need roughs. I think it's going to come down to finding facilities out there that have zoysia grass fairways, zoysia grass greens, paspalum greens, so that we can work with them, especially if they have a nursery green, to at least evaluate a couple PGRs. We did this with PGA Frisco last year. It works pretty well. We fly out with our equipment. We line out all the plots, make all the apps, and the guys down there did a fantastic job of collecting the clippings and then sending them up here, where then we weigh them and clean them and do the modeling. But that's a little bit of the approach that we're going to need is to find courses that have paspalum or zoysia that are interested in having us out. The other tricky part of that is they need to have a drying oven. So PGA Frisco have a drying oven. They like to sieve out their sand they get from their top dressing supplier before they sign off on it, and for the delivery. So they already had a drying oven. So that really helped with the process. It's going to take about 30 to 40 minutes a day for a small study, 3 to 4 times a week for a period of about a month to 6 weeks. So it is a labor commitment. to get those numbers. But if there's anyone out there that wants to help us, like the PGA Frisco data now, that data is the data set that GreenKeeper is using. So if you're a GreenKeeper user, you would know that the models we built are modeled from your golf course, to kind of help us to figure some of those aspects out.
Well,
I think more large scale with managing growth rate, we're working to integrate the Doug Soldat's machine learning models to predict grass growth rate at your own course. And so over time, the estimated amount of suppression coming from GreenKeeper is just another metric that the machine learning models can use. So they can help optimize site-specific models based on all kinds of factors. So that's going to really help get to the broader point of how much suppression do you need, how long do these products last. That would just be another important variable in that complex model, and can't wait to get that released here this summer.
cool. That's the machine learning that you're talking about.
Yep. So even if Greenkeeper's prediction says that you have 50% suppression on paspalum today, and it's really 30%, through repeated measurements of clipping data, it kind of recalibrates itself. It's the same idea as your soil moisture meter. If it's saying it's 20%, but it's really the true value is 15%, but you're at least managing with that consistent number from your moisture meter, even if it's not precisely accurate to what the amount of water in the soil is, as long as it's the same every day, then you can still use it to make management decisions.
Okay, I think I sort of understand about that. So if you're tracking the clipping volume, then it's gonna tell you how you're deviating from normal for your site based
Yep.
on, because it knows your weather and it knows how much clipping volume you've been getting for certain types of weather, and so it's then going to know what your relative suppression is.
Exactly. So even if it thinks it's a 30% factor and it really might be more or less, it will start normalizing to account for that, which then will help with the recommendation for the PGR rates and intervals. So that's a longer play. Right now we still would love to develop some ground truth models, the old-fashioned way of collecting clippings and weighing thousands of them a year from each site, to just get a good rough number, but so that number in GreenKeeper can be as close as possible, and then the machine learning will start to pick up on subtle differences that are site specific.
How close is clipping volume to dry weight when you run a regression on that?
It's pretty good. I think we've done it with your data. We've done it with Doug's data. I don't know the number on the top of my head in terms of an R-squared value. You do get into, the law of big numbers. So if you have the days that are higher due or less due, if you collect 200 measurements over the course of that season, you're going to start falling to whatever that mean number is. So the more that you're sampling with consistency, and just like any kind of data collection, I don't care if it's soil testing, moisture meter, clipping volume, green speed, it's all about consistency and sampling the same way, the same site, the same interval. Then a lot of that noise starts to center around what the true value is. And so we can start to zero in on what that is simply by doing regular sampling.
Yeah, I think it works out really good on the average, but it can be all over the
Exactly.
place. I just wonder whether you couldn't do this type of study because I've thought that we could do something good enough to check like Zoysia fairways by doing a whole bunch of sites and just looking at clipping volume, so we don't actually have to weigh anything, and
Yeah, and
try to
we're trying
figure
to
out the duration of the effect, or the
well, we're trying
duration
to
of the
take that.
suppression.
That's the sensor mounted advancement is a way to help do a pseudo clipping volume. I think clipping volume on a green or an infield of a baseball field is, or maybe even within like a 10-yard line stripe on a football field, or whatever you want to have for your standard measurement area. That's still is the gold standard, even though it might seem a little crude. Again, average across a 7-day average is what we recommend, or look at a cumulative clipping removal as from a yearly basis, then that number is a lot more actionable compared to the day-to-day number. When you go to these larger areas like outfields or large soccer fields or even fairways, we think that some of these different sensor technologies, mower mounted sensors, active sensors that have their own light source, so you can do it, make measurements at night and dawn during the peak of the day, get a repeatable number out of it. That will at least give us a better indication of estimate of what the growth is over a larger area. And so I think that they kind of complement each other. Clipping volume is the best. Sensor data is a way to collect a lot of geospatial data to get an estimate of what growth rate is on broader areas.
This is fascinating. I want to talk a little bit about the problem that could happen if you apply at the, let's say you're applying at a perfect rate. And so let's say that I'm getting a clipping volume of 20 milliliters per square meter, which is 2 liters per 100 square meters, which is approximately 2 quarts per 1,000 square feet. So that's my clipping volume. That's my growth rate. And I think, that's a little bit faster than I want. Let's say it's peak season. It's the middle of the growing season. And that's a little bit faster than I want. It's a little bit more clippings than I want. So I decide that I'm going to apply growth regulators with an objective of having 50% suppression. And so that's the type of rate that I target. And then what if I get it all wrong with my reapplication intervals, however, and I do what Dr. Rossi calls stacking, or what do you call it? Do you call it stacking?
Yeah, I've just taken his his
So
nomenclature here. Yeah, stacking is fine. Um, the crude example we give is kind of like drinking alcohol. If you're drinking it faster than your body is breaking it down, it's going to accumulate in your body, and you're going to get a little drunk. And so I don't care if you're drinking big shot glass, like a shot glass of beer. It's a small quantity, but if you're doing it every minute, it's still going to be accumulating in your body, and you're going to lead to feeling a little bit tipsy. If you take that same approach, where if I'm using Primo at 2 ounces, even though it's labeled at 5 ounces, but I'm applying it too frequently, um, 2 ounces becomes 4, becomes 6, and you just keep adding more and more active ingredient to that plant, and therefore the effective dose is greater. A 2-ounce rate of Primo on a Bermuda grass green versus a 4-ounce rate of Primo lasts the same amount of time. So if you're going out and saying, I'm going to put 2 ounces down, and then 3 days later put 2 more ounces down, you might as well just put 4 ounces down at one time, because that's essentially how much is going to be there, and it's going to last for a pretty long, 2 to 3 weeks, depending on the weather. 2 weeks in the Bangkok weather that you talked about at the start of the podcast here.
So and you visit a lot of turfgrass sites. You do consulting. You speak at conferences, and you exhibit at conferences, and you talk to a lot of turfgrass managers. How common do you think it is that people apply plant growth regulators too frequently?
I think it's pretty common. I think we're seeing a lot of that on the Bermuda grasses in the southeast, where we're having weekly intervals, even through the winter with the cooler weather. It's a little harder on the cool season grasses to generally over apply. Even if you're applying weekly, when it's summer, that might be a pretty correct interval. Maybe it's 10 days. And if you're doing 7 days, that's not that big of a deal. On the other side, though, I see a lot of issues on the cool season world where in the spring, they'll do proxy and new, or proxy primo. They'll throw in Balaton or Banner Max for some DMI fungicide. Then they'll start doing, a week later, they'll come out with some Trim It, and then Trim It in a new. And then next thing you know, you've made 4 applications in the matter of 3 weeks when it's really cold. And you can easily have 70% suppression, and that bentgrass doesn't want to grow. And even in that scenario, that can actually favor POA, because now the bentgrass is just breaking dormancy. The POA is already going. So yeah, the POA is being suppressed by 70%, but so is the bentgrass. And so that bentgrass that's growing at essentially nothing is really growing at nothing. The POA that was growing is still growing. It still has an ecological advantage over that bentgrass that's trying to green up. And so I don't like doing too much suppression early spring and late fall, because you actually can favor annual bluegrass that way. And then I think on the warm season side, we just see these weekly intervals that are just too tight, when we should be closer to a 2 or sometimes 3 or 4 week interval on these materials that can lead to stacking and can really be problematic and quickly result in 85, 90% growth suppression.
What
So I
what
think the knee-jerk reaction is then to fertilize more on the bentgrass green side. Let's fertilize more in the spring to get that bentgrass growing. Okay, that's helping the bent, but it's really helping the POA. It's again exacerbating the problem, or the ecology is backwards. Or if we're on the Bermuda grass side, now we're putting down 2, 3, 4 times more fertilizer to get it to grow at that acceptable rate to be able to handle all the traffic that turf is under. And so we're trying to fix a problem with another problem that could be leading to thatch accumulation or require more cultivation, and potentially has negative impacts on our groundwater and surface water. So we don't want the PGRs and the DMIs to be the problem. Let's let them be the tool to help us hit goals. And so the first part is having some goals to try to manage towards.
and and that might include playability measurements, and it might include growth rate measurements.
Yep,
Is that what you
exactly.
mean? I was
Yeah,
gonna.
so we have those 3 greens. We stimp every day from the same spots on every green, and we do clipping volume every day from the same greens. And then we make our adjustments as to, do we need to double mow? Do we need to roll more? Do we just roll? And then we can decide about top dressing rates. If it's a high clipping volume week and we have to top dress, we'll do a little more sand. And then we'll just schedule our PGRs to follow suit if we need more or less. But we're still using it to hit a goal, and we're not just applying these materials haphazardly.
I have a question about visual symptoms of over regulation of 80 or 90% when you'd rather have 50%. So you mentioned that this does happen. It might be a little bit more common on warm season grasses. And you said on cool season grasses, I think you explained it pretty well, that it's more of a problem in spring and in autumn, and you might be having Poa annua that could compete well against
Yeah.
bent grass if you over apply. I was curious about, with ultra dwarf Bermuda grass greens, what would some visual symptoms be of this effect?
So for both, there's 2 types of negative visual quality results from the PGRs for both warm and cool season. If you go out with an application by itself, and there's no past applications or prior applications, that is the higher risk of seeing a yellowing, bronzing phytotoxicity. So I don't care if you're using Trim It or Primo or Renew. If you come out and just do a full rate, there's a higher likelihood of seeing a problem than if you work your way up. So if you use a low rate of Trim It, say at 4 ounces per acre, and go up to 16 ounces per acre, I'll never see phyto out of that approach. But if I came out and did a 10 ounce per acre rate in the middle of July without that preconditioning, then I'll see this phyto that's more of the yellowing. We see the same thing in our research plots. That Jim Kearns had a pretty good one of their applications. We saw this yellowing, this bronzing color after their Renew and their Primo applications in the first one, and then subsequent applications you didn't see it as bad. So that's your kind of chronic, or your acute phytotoxicity. More of a chronic type of phytotoxicity is you see segregation. The bent grasses and the POAs get this real like blue, sunken, brownish hue to it. The Bermuda grass, there's some researchers thinking that some of the segregation issues that they're seeing with the different patches within the greens, off types, they also may be a result of these really aggressive PGR programs. And then some of the pathologists are even suggesting that some of these newer diseases, especially in the spring and the fall, when the Bermuda grasses don't want to grow, but we're still on weekly intervals, can be leading to different types of root diseases, maybe things like take-all root rot, or the Pythium outbreaks we're seeing now. How much of that's related to overregulation? And that's still their hypothesis, hasn't been really tested yet, but those are some of the chronic challenges that can occur from too much suppression.
Okay, thank you very much. And I would speculate also that if you get the growth regulation wrong, and then you also apply nutrients way out of whack with the time of the year that the grass can use it, I think, and this is pure speculation, and I'm not a plant pathologist, but it scares me. I mean, I wouldn't manage my grass that way because I would be afraid that I'm feeding the fungal diseases. So it's like you're
Yeah.
suppressing the grass, you're over fertilizing with all kinds of nitrogen and other things. And at the times of the year when the grass can't use it, that to me is a scary thing. And it seems like, I mean, it's something that I speculate would possibly lead to increased diseases.
Mm-hmm. Yeah, and we think about things like Pythiums and Rhizox; those are generally high fertility type pathogens. And so you could see how you're suppressing growth of the plants, potentially not up to full potential to grow through. And then we're also putting so much fertilizer down that might even be favoring these pathogens to be a little bit more competitive than they would be in a native, natural environment. So just kind of some curiosities there that I think we need to keep looking into.
Yeah, wonderful. Well, we've talked about almost everything on my list,
Okay.
PGR Bill. But while I have you here, I've got a question about seed head suppression, especially on Zoysia. But I know there's seed head plant growth regulators are used for seed head suppression on Poa annua quite commonly. Do you? And I know you know a lot about making healthy grass and about suppressing growth. Do you also know about seed head suppression and the role of plant growth regulators in that?
More in the cool season environment. So I'm going to defer any seed control for the warm season grasses.
Who
Just
who do?
haven't had the experience, and I don't really want to.
Thank you. So who do I want? Who do I need to talk to about that? Who's the best person for warm season? Because I've
Mm,
seen like there's really you look at like proxy. What's the active ingredient in proxy?
Ethithon.
Ethifon.
Hmm.
You look at the effect of Ethifon on Zoysia seed head suppression, and there's like conflicting research. Um,
Yeah, that's what I've
so it's
seen
like I
too.
absolutely can't recommend that because some people applied it, and the photos are shocking. Where they applied Ethifon, there were way more seed heads.
Yeah, I think I don't really know who's doing that research, and if someone hears, I apologize if they're doing good work there. I just don't know who that person is off the top of my head. I know there's still some work in the cool season world of optimizing. I think these late fall applications of Ethithon have really helped out
Hmm.
to get much better seed head control from any seed heads that are developing late fall, early winter. So a big proponent of that. And then my sequential apps in the spring. We use growing degree day models for the first one, and then we also use a growing degree day model, 200 growing degree days for the second one, which is generally around 2 to 3 weeks in most climates when their first one's going down. Um, but on the warm season side, I don't have good information, unfortunately.
Yeah, it's interesting because in a tropical environment where the day lengths don't vary much, with a grass like zoysia in the U.S., even in the far southern parts of the continental U.S., that's quite far from the equator, and so the day length varies quite a bit. So you get
Mm-hmm.
long days in the summer where the grass can't. Zoysia grasses won't produce seed heads when the days are long, And then so you only get seed head production in the autumn if the temperatures are still warm enough when the when the day lengths come back under 12 hours per day. And but the seed heads are formed then, but they often won't show in the autumn because the temperatures are too cold. And then they show in the springtime when the temperatures warm up. But then as soon as the temperatures warm up, the day lengths are quickly 13, 14 hours a day, and you don't have seed heads anymore. So in Zoysia in the United States, it's just like you sometimes see a little bit in the autumn, and then you get this spring flush, and then that's it. It's over with. But you
Hmm.
get closer to the equator, and suddenly you have a large part of the year where you've got both the two things that you need for zoysia seed heads are high temperatures and short days. And as you get closer to the equator, you end up either with year-round seed head production, or you end up with seed head production that can last for 4 months or 5 months. And and a lot of the Asian varieties of zoysia grasses that are used here don't have so much seed head production, but the ones that are bred in the U.S. and then they're bred in the U.S., they're evaluated in the U.S. in these places that have this type of long day in the summer, short day in the winter type of phenomenon, or type of climate and day length. So they it's the seed heads are not such an issue, but then you come plant it closer to the equator, and some of these varieties seem to have a lot more seed heads. So it's interesting. I'm interested to know like why that
Yeah.
happens and how it can be reduced. Yeah, I asked Ambika Chandra, Dr.
Yeah.
Chandra, about that, and actually wanted to do a ATC office hours with her, and maybe I will try again and see if she's available because I think she would know about this pretty well.
Yeah, I would guess definitely, and that's in her expertise area for sure. So,
All right. Well, Dr.
um,
Kreuser, I think we've talked a little bit longer. How long does it take you to mow greens? If you would listen to this episode, would that be a 1 acre greens mow?
yeah,
Uh,
we would be about done. So I'd be up washing right now, be soaking wet, trying to to get on to the next job. But I appreciate you having me. I think instead of having my own podcast, I'll just join yours. If you ever need me, just give me a call. And I appreciate the opportunity to talk about our research, to talk about how Greenkeeper is helping to use some of our models to give confidence. Ultimately, it's a decision support tool. It's there just to help make the right decision. And so I'm excited about how people have been signing up and supporting our small little 6-person company, and ultimately help that we're improving the turf grass quality golf courses and sports fields around the world. So thank you.
all right. Well, thank you for joining me on relatively short notice and for answering so many of my questions. And I hope a lot of the viewers and listeners will also uh, have some of these same questions that you have clarified the answers for them. So this is certainly an interesting topic, and I'm glad that you also see such a value in clipping volume and just knowing what the growth rate is, and then using growth regulators as a tool to achieve that. And so, yeah, I think probably I'll try to blog about that some this year and talk with a lot of the people that I work with to make sure that they're getting the most effective use of their growth regulators. So, in the show notes, the show description, you will be able to find all kinds of links to my website, asianturfgrass.com, to Bill's Twitter account, to the blog post that we started off talking about, to some of the research articles, to the GreenKeeper app, and so on. Thanks a lot, Bill. And thanks everyone for listening. And I will now sign off for ATC from Yantakao, Thailand. I am Micah Woods. Bye bye.